Okay, in part B, what we want to do is estimate the median from the histogram. Now, what I've done is I've just taken the histogram that was given in the question, and in each bar I've written down the area. We worked out these areas in part A when we were getting the mean. I've also added all of these areas together to get the total frequency, which we did in part A, and that's 260. So remember, the significance of the area of each bar is the number of cars. So if you take the first bar, that represents 25 cars who had to wait between 0 and 20 minutes in a car park, and so on. So we want to get the median from a histogram. So the first thing we've got to do is get the location of the median. Now, the formula we use for the location, because the data is grouped, is a half n. And remember, n is the total number of data values. Now, in this case, the total number of data values is the total number of cars, which is 260. So a half multiplied by 260 is going to give us 130. So what that means is the location of the median is the 130th car. We now want to get the actual median, which is the time taken, or the time that the 130th car had to wait for. So we're now going to get the actual. So what we need to do now is we need to identify the sub-bar within the histogram such that its area and the area to the left of that bar is 130. So if you go to the histogram that we have, the first bar is 25. So that means this vertical line here, which is in line with 20, that is the waiting time of the 25th car. So this bar contains 25 cars. The bar ends, the line where it ends, is the time taken by the 25th car. This bar here contains 45 cars, so where this bar ends is not the waiting time of the 45th car, it's the waiting time of the 45th plus the 25th, which is going to give us 70. So this is the waiting time of the 70th car. The 70th car would have a waiting time of 50 minutes. So what we're trying to do is get the waiting time of the 130th car. So if we add these two areas together like we did, we've got 70. So the total area to the left of this line is 70. We're trying to work out where we can put a vertical line such that the total area to the left of it is 130. Well, the line we're going to put in is going to be somewhere within this bar, because this bar contains 100 data values and these two bars are 45 and 25. So 100 plus 45 plus 25 is going to give us 170. So this line here would be the waiting time of the 170th car, which is too big. So the 130th car must be somewhere in here. So what we do is we draw the bars out as far as the 130th car. So there's the first bar. So it's got an area of 25. So it ends at 20 on the horizontal axis. So that's the waiting time of the 25th car. Let's take our second bar. So the second bar contains an area of 45, and that bar ends at 50 on the horizontal axis. Now, that's the waiting time off, not the 45th car, because you add all the areas to the left of that line, so that's 45 plus 25 is going to give us 70. So that's the waiting time of the 70th car. Now, we're into the third bar. We're not going to draw the entire third bar because that would give us the 170th car. So we're only going to draw part of that bar, which is called a sub-bar. So I'm going to draw a sub-bar. So it's going to be a wee bit shorter in length. Its height's going to stay the same. So it starts at 50 where the previous bar ended. We're only looking for an area in the sub-bar of 60 because that would make this vertical line here the waiting time of the 130th car, because if you think about it, there's 25 plus 45 is 70, 70 plus another 60 is 130. So that vertical line there would be the waiting time of the 130th car. Now, we need to work out what this value is here, because that is going to be the median time. That's going to be the actual median, which is what we're after. So we know the area of this little sub-bar. We also know the height of the sub-bar, because the height of that sub-bar is going to be the same as the height of the original bar that contains it. So it's 2. So that bar is 2 units high. And its area is 60. So what we can do now is work out the length of this sub-bar. So the length of the sub-bar is going to be the area divided by its height. Okay, so So 60 divided by 2, which is going to give us 30. So we've just worked out the length. The length of the sub-bar is 30. So all we do now to get what the actual median is we add 30 on to 50. So actual median is going to be 50 plus 30, and that's going to give us 80 minutes. And that's how you get the actual median from a histogram. Get its location, then you have to identify the sub-bar within the histogram, such that the total area inside the sub-bar and the bars before it adds up to give you the location for the median, which is 130. Once you've got that sub-bar, you should know its height. You also now know its area. Divide its area by its height to get its length. Add the length on to where that bar starts, and then that's going to give you your actual median.